The line passes through the center or the line joining 2 points on the circumference through the center. You know the name called as diameter. It's diameter equal 2 times the radius. Okay. Another portion we need to remember. Portion of a circle. A portion of a circle covered with radius. Like this, a portion of a circle covered with radius. This portion is covered with radius. So tell me the name. You know the name? The name is sector. So we call it as sector. So the center, the circumference, this part is the circumference because part of the circle. So the circumference, a portion of a circumference is there. We have another special name for that, called as arc length. So portion of a circumference we called as arc length. The ending of the end points of the arc length connected to a point. That point is always the center. So if this is a part of a circumference, so the distance between the circumference and the center, so this length are radius. In other words, we can say sector is covered with radius. So those are the key elements to we need to recall to study area of the sector. And the other part is one of the important part is we have an angle. We have an angle inside the sector. If you want to find perimeter or area of a sector, the angle at the center, angle formed by the center or angle inside the sector, we need that angle to calculate the area and perimeter. So the radius, you need to identify what is radius, what is the arc length, what is the angle. If you know all the details, we can find the area of the circle. Okay, area of the circle, we all know the equation is pi r square. Area of the circle we called as pi r square, what we studied in grade 9. Okay, we'll recall what we studied, how we get this equation. Okay, so circle with a radius r, we are going to divide this circle into equal 8 portions to find the area. Okay, this is the center. So the radius is r. So we divided this circle into 8 portions. So we are going to keep those individual portions in a rectangular shape. So we keep them in a rectangular shape like this. First sector, the second one, and the third one. Like this, we can keep those sectors. So we can arrange those sectors into a rectangular shape, not exactly a rectangle, a rectangular shape. Okay. This length we called as circumference. So circumference of a circle with radius r, we can calculate 2 pi r. We studied in the perimeter. So circumference of the circle with radius r is 2 pi r. So if you observe this figure, we 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 divided the circle into 8 portions and we made it in the shape of rectangle. If you check these arc lengths, we have 8 portions, 4 portions are there, which means we divide into 8 portions. 4 portions means half of the circle, half of the circumference. Okay, half of the circumference is on the top and the other half is in the bottom. So what is the length of these 4 arc lengths? So entire is 2 pi r, so half is pi r. So the length of this rectangular shape we can take as pi r. So what is the breadth of this rectangular shape? This length is called as radius. So the breadth is r. So likewise, we convert circle into a rectangular shape. Now the area of the rectangle in this rectangle is equal to area of the circle. Okay, that's how we derive this equation. So area of the circle is equal to area of this rectangle. So area of the rectangle is length into breadth. So length is pi r and the breadth is r. So finally area is pi r square. So that's how we derive the equation of area of a circle. So these are we studied in grade 9. So now we are going to deal with part of circle. What is the part of the circle we are calling? The part of the circle is called as sectors. So how do we find area of the sector and what are the equations we are going to use to find the area of those sectors? Okay, we'll go for it. So this is your grade 10 portion. What you are going to study in grade 10. So the primary portions we can get from a circle. So first one, we can get a half of a circle. Half of a circle we called as semicircle. So semicircle with radius r. So half of a circle. So the circle area of the circle is pi r square. Area of a circle is pi r square. So we have half of the portion. So this is a sector, half of the whole. So area, we all know, using the knowledge of perimeter, we can easily tell. So area of a semicircle is half into pi r square. Because we have only the half of the portion. So half of the whole. Half of the whole. Whole circle is pi r square. We have the portion of half. So we know semicircle is half of the portion. So that's why we can directly write what portion of this of the circle. Okay. The second we can directly write it's a quarter circle. So we can recall this what we studied in perimeter in grade 10. Likewise, we studied and we get the equation of the perimeter. So recall all these ideas. So this is not a new thing you are learning. This is already you learned with perimeter. So radius r, a sector with the center angle 90. Semicircle, the center angle is 180. Okay, if the center angle is 90, we call the sector as quarter circle. Quarter circle means we all know it's one of if you divided for equal 4 parts a circle, one of the portion is the quarter circle. So the area of the quarter circle entire is pi r squared. So here we have 1/4 or 1/4 into pi r squared. So this is how we studied the perimeter. The third portion we can easily directly we can write the portion, because half we all know, quarter we all know, we can directly write it. So these are also sectors, but with the special name they are calling, because the with the portion. This is also a sector covered with two radius and the part of a circumference, covered with two radius, part of the circumference. But we exactly know the portion of these sectors. Okay. The third one is a 3/4. So the angle is 270 with radius r, 3/4. So area we can tell 3/4 into pi r square. 3/4 into pi r square. So these three are primary. Using the image, using the figure, we can easily identify which portion of this circle. But instead of these three, if you give a sector with the center angle 30, radius is r, center angle 30, radius is r. If you can tell directly, like the half, 1/4 and 3/4, what is the portion of this sector to the entire? So it is, we need a calculation, we need some time to calculate it. These three, using the figure, we can easily tell the portion: half, quarter, 3/4. 30 we can't. So when it comes to an angle with 45, so what is the portion? If we know the portion, we can tell with the portion into pi r square, that is the area. Okay, so we need another form of formula. It is very similar to the formula of perimeter. Okay, so இதே ஸ்டைல்ல தான் நாங்க பெரிமீட்டருக்குரிய ஈக்குவேஷனும் எடுத்தோம். அதே ஸ்டைல்ல தான் நாங்க ஏரியாக்குரிய ஈக்குவேஷனுக்கு போறோம். So portion of a circle, how do we find the portion of circle? So how do we found semicircle as half? Always the portion of the circle found by the center angle. Half னு சொல்லி அங்க a வந்துச்சு, எப்படி வந்துச்சுன்னு சொன்னா, for a circle, angle around a point is 360. So 360 semicircle, in the semicircle we have, what is the center angle? 180. So the portion of the semicircle to the entire is half. When it comes to a quarter circle, the center angle is 90 from 360. So we can easily find the portion is 1/4. For a 3/4 circle, so the angle is 270 to 360 out of 360. So the portion is divided by 9, it's 4 and 3. So 3/4. So the angle around the point is 360. What is the angle of this sector? So using these two values, we can find what portion of the sector is given. Okay, for 30 and 45. So what portion of the circle is given with the angle of 30? So angle at the center is 360. Around the point is 360. So out of 360, how much we have? 30. So what portion of the sector is given by angle 30 is 1/12. So if you know the portion of the sector, we can multiply with the pi r square. So area of this sector is 1/12 into pi r square. Okay. So likewise, we can derive an equation for all of the sectors. All of the sectors mean the primary three sectors what we have discussed are semicircle, quarter circle, and the 3/4 circle. you can also use this equation. So area of a sector is given by the center angle theta over 360. Theta is center angle of the given sector into area of the circle pi r square. Area of the circle pi r square. So it is more similar to the area perimeter of a sector. Theta over 360 into 2 pi r. Instead of pi r squared, we use 2 pi r. So here we are using pi r squared. Okay, so this is the equation. So you can find whatever the sector is given. If the center angle is given, so you can find the portion of the sector. So theta over 360 into pi r square is given the area. Okay, we'll discuss some examples, and we can familiar with this equation. How do we use this equation? Okay, first example question: draw a semicircle with radius 14 centimeter. Okay, find the area of the given sector. Find the area of the given sector. The sector is semicircle, so we directly know the portion. So area is equal to half into pi r square. When you know the portion directly, you can apply the portion directly to the equation. When you have the out of the basic three, semicircle, quarter circle, and the three-quarter circle, out of these three, we are going to use theta over 360. Okay, so we are going to substitute the values. So half into 22 over 7 into r squared. We are going to use r squared with individual values. R squared means we all know r into r. So we are always substitute the radius as a multiplication, not in the power form. So the radius is 14. So 14 into 14. So we are not using 14 squared because it's easy to simplify when we write separately. Okay, we can do the simplification. 7 times 1, 7 times 2, 2 times 1, 2 times 1. So it is 22 into 14. So 22 into 10, 220. 4 into 22, it's 88. So it's 308. So 308. The area is 308. So here, half, we don't have a measurement. 2207 pi, we don't have a measurement. But 14, the radius, we have a measurement. What is the measurement is given? Centimeter. So here we have a centimeter and centimeter going to be multiplied. So centimeter into centimeter, area is mentioned with a square. So 308 square centimeter. The measurement is square centimeter. Okay. Okay, the second and third examples, we have two figures. Draw this figure. In the second question, we have given a sector with the angle, center angle is 70, the radius is 3 centimeter. So here we don't know the exact portion of this sector. So we are going to use the equation theta over 360 into pi r square. If you know the exact portion, we can instead of theta over 360, we can use the portion. So 70 over 360, substitution, 22 over 7, the radius is 3 into 3. Okay, you can cut off the zeros, 7 times 1, 7 times 1, divided by 3, 3 times 1, 36 is 12, divided by another 3, 12 is 4 times. Divided by 2, it's 2 times. It's 11. So 11 over 2. 11 over 2. Finally, the answer is 5.5 centimeter square centimeter. Because 3 into 3, those are the measurement with the centimeter. So square centimeter, 5.5 square centimeter. In here, we found the portion of the sector given by theta over 360. That is the extra part in grade 10. Okay, go for the third question. Pause this video and do the working. After you do the working, continue this video. So the center angle of this sector is given as 108 and the radius is given as 7 centimeter. So we don't know directly what is the portion of this sector. So we are going to use the equation. So area equal theta over 360 into pi r square. So theta is 108 over 360, 22 over 7 into 7 into 7. So we do the simplification. 7 times 1, 7 times 1, 360, 108. So 108, familiar with the numbers, 108 we can divide by 9 or we can divide it by 6. So you can use. So divided by 6, 36 is 6 times 108, 10 1 time, remaining is 4. So 48, 8 times. Okay, divided by 66, it's 10 times, divided by 18, 6 is 3. So now we have to multiply it. So we denominator we have 10. So it is easy to convert into decimal. So 3 into 22 into 7. So 3 into 7, 21. 21 into 22. So 2, 4, 6, 462. 462 over 10. So 46.2 square centimeter. That is the area. So that's how we are going to use this equation when the angle at the center of the sector and the radius is given. We are going to use this equation. Okay, the fourth and fifth examples, we have given 2 sectors. The area of the sector is given and the angle of the center is given. We need to find the radius. So write a question. Area of the sector, area of the given sector is 154 centimeter square. Find the radius of this sector. That is your question. Okay, write the question, draw the figure. So we mark the radius as R. Okay, so the sector angle, the center angle is 90. So this is a primary sector. So we know this portion. What is the portion of the sector? So we can directly add the portion. So area is equal to 104 into pi r square. So the area is given 154. So 104 into 22 over 7 into r square. The radius is r. So we need to find the r. So if you subject the r, you studied in grade 9 how to subject the element. Subject means you have to keep the unknown term one side of the equation, send the other values to the other side of the equation. Okay, so we need to send individually other side of the equation in one step. So if you send all these values, so r squared is remaining. So r squared equal, on the other side we have 154, 4 and 7. Those values are in division. If you send it, it will be changed as multiplication. So it will multiply with 154. So 4 into 7. So 22 is multiplied with the R. So if you send it the other side of the equation, it will divide. So 22. Carefully, without mistake, send it. So I send it with one step. If you need more steps, if you want to send individually, do it. So you studied it, how to send it, how to subject a unknown term, how to subject a algebraical term. The lesson in grade 9 formula, you studied it. Okay, now the simplification, the next step, we can divide by 2, 22 divided by 2, it's 11, divided by 154, 15 7 times, 1 remaining 14 7 times. So divided by 11, 1 divided by 7, it's 7. So r squared is equal to 7 into 7, 49 into 4. Don't multiply every digit. If you multiply and you'll gain a larger number, it is difficult to simplify or difficult to create idea. If you keep with similar manner or small values, we can easily gain ideas. So I multiply only 7 and 7. So 7 into 7, 49 and 4. I keep the 4 because we are going to find the square root. Okay, in grade 9, we studied Pythagoras theorem. Using the Pythagoras theorem, we studied square root. Okay, and then in grade 9, we studied square root. Okay, using those values, you can find the square root of r. So r equal, if you send the square other side of the equation, it will be square root 49 into 4. So you know why I multiply only the sevens, because 49 is a perfect square. We have a value 4, it's a perfect square. That's why I didn't multiply. So if you find the square root of 49, it's 7. Square root of 4, it's 2. So the radius, finally the radius is 14 centimeter. So the area is given. You need to find the radius. Okay. So you have another question, do the question and continue this video. So we are going for the fifth one. So write the question for the fifth one figure. Area of the given sector is 264 square centimeter. Find the radius of the sector. Okay. In this sector, if you observe it clearly, the angle at the center of the sector is not given. The angle of the sector is inside the sector. It's not the outside angle, but the outside angle is given. So we need to find first what is the angle at the center. So angle around the point is 360, we all know. So the given is 150, so the remaining is 210, because altogether it's 360. So now we know the center angle of this sector, that is 210. So we have the area. So we take the radius as r. So in here, the angle is 210. So we don't know the exact portion of this sector. So we are going to use the theta over 360 equation. So area equal theta over 360 into pi r square. So we are going to substitute all the values. Theta, it's 210 over 360 into 22 over 7. R is r squared. The area is 264. So we can simplify some of the values here. 0, 0, 3 times 12, 3 times 7. Okay, 7 times 1, 7 times 1. Okay, now we have 22 on numerator, 12 on the denominator. We are going to subject the r square. So r squared equal 12 will multiply with 264. 264 into 12 over 22. So do the simplification, divided by 2, it's 11, divided by 2, 1, 3, 2. Okay, we can divide 132 and 11. So 11 times 1, 13 one time, remaining is 2, 22, it's 2 times. So 12 into 12. So r squared equal square root of 12, sorry, r squared equal 12 into 12. You don't want to multiply it. If you multiply, it's okay. So r equal square root of 12 into 12. Grade 9 we studied, if two same values multiply inside the square root, so the answer is one of the value, 12. 12 centimeter is the radius. So likewise, in the fourth and fifth question, the angle and the area is given. You need to find the radius. Instead of angle, they gave the radius and the area. The question will be find the angle at the center. Okay, likewise, we are going to use this equation. So the first part, primary part, we studied and we discussed with these exercises. So now you can complete the exercise 6.1.